Good morning. Thanks for joining. I think the 5G networking infrastructure is already here. One of the things I plan to talk about is it a revolution or just evolution from LTE to yet another technology? So you'll see in my presentation, I try to point out to examples where 5G is different and what we are doing about it. So this is the data point that everybody knows. This data is changing constantly. You heard from Dish yesterday that they are bringing up many cities in the next few days. So that's going to add to this data. But the 5G infrastructure, definitely commercial deployments are up there. They will continue to be there for next 3 years. We have heard about next G, 6G. Those efforts have started already, but it will take time to get to the next generation before you finish all the infrastructure spending and deployments in 5G, in my opinion. So when you talk about 5G, I would like to point out there are 3 main pillars that I believe differentiate 5G from any of the previous generations of mobile networks. First is the use of network slicing and management, which allows you to create virtual networks for each of the different services, give them a slice of the network bandwidth, and protect it from other users so that you can provide assured SLA and experiences. The second is distributed architecture. Because of 5G densification, the architecture of how the mobile networks are designed is changing, creating thousands of mini edge clouds, which act as aggregation points. And distribution of these mini edge clouds and their management orchestration is a big challenge. And lastly, the telcos with this generation first time formed an alliance called O-RAN Alliance to encourage the creation of an open ecosystem so they do not have to source vertically integrated systems from a couple of vendors. And that is an exciting opportunity for vendors like Juniper, which is also participating along with other people who believe in supporting open, interoperable interfaces and ecosystem. So I'm going to talk about each of these pillars, starting with, of course, a need for network slicing. If you look at the 4G and other monolithic networks, they were providing one kind of a basic connectivity, one-size-fits-all kind of a network. With 5G network slicing, what we are trying to do here is that provide dedicated end-to-end virtual networks per user or per tenant or per use case or per service that can be allocated bandwidth and can be protected, right? And once you have that prescribed quality of service, you can enforce it to make sure that you can also start providing service on an end-to-end basis, not just in radio access network, but you have to take the notion of slicing and extend it into across multiple domains, such as transport, core, and even public cloud. And that's the end-to-end slicing that comes with 5G. Just to go one level deeper in the 5G network slicing, the architecture shows what are the main components when you disaggregate the vertically integrated stack. You have a RU, of course, very closer to the endpoints. You have a central unit, distribution unit. They are distributed across the network, across the RAN, depending on the sites and cells you have. And you have this control point called RAN intelligence controller, which acts like an operating system for the radio access network, right? And it has 2 components, non-real-time and near real-time. Non-real-time runs what is known as RApps, which are responsible for providing functionality such as slicing, which defines slices for each of the virtual networks based on tenants and use cases. And then it makes sure that based on that, it calculates the SLA policy, the slice policy, that it can hand off to the xApp running on the near real-time rig, which implements those by making configuration changes, allocating PDUs, and so on. Now, as part of the orchestration, you also have non-real-time rig constantly monitoring the SLA for each of the slices allocated. If it says any deviation from that, it recalculates some configuration changes, slice changes, puts that policy back into RApp, from RApp to xApp, and xApp implements that. And that's how you constantly make sure you can provide assured experience for each of the slices. Here's an example of actual use case that Rakuten did in one of the soccer stadiums, where they gave the people attending the game an application that can run on any phone. And that application, once downloaded, had a real example of augmented reality. available in the stadium itself, where you could point the camera of the phone to the pitch and you could get information on team formations, different strategies, and so on. If you pointed at a player, you got his player stats. If you pointed at a team, then you of course got team's schedule, team's information, but also you could go to the team's website and buy gear. So you have some e-commerce also to monetize such services. This is the example of thing now being also done in other places, such as SAP Center now just announced that they will have a gigabit speed private 5G network to enable such use cases. The second pillar I mentioned is distributed architectures. As I said, because of 5G densification, there's a need to have these hundreds of or thousands of mini edge clouds, apart from the telco cloud where packet core might be located, or you might use public cloud for packet core, other components in telco cloud, and these hundreds of thousands of mini edge clouds. All of those need to be orchestrated, managed in automated fashion using cloud native architecture, taking advantage of Kubernetes-like stacks. Because the telcos traditionally have not been able to do that in OpenStack environment. It has been a big challenge up till now to manage this kind of clouds. Now this is a very different problem with distributed architecture. And together I think we have to help the operators solve this problem using automation as much as possible. So all of these distributed architectures ultimately will be supplied or supported through an integrated cloud that has built-in analytics, security. It is a software-defined network, and of course it supports remote edges and so on. One of the things we are doing in this particular environment to make it easier for telcos to be able to get this kind of distributed architectures in production seamlessly and without much effort is partner with IBM. IBM Marketplace has multiple of these products available, including products from us such as Apstra's Fabric Management, our Fabric components or third-party Fabric components that Apstra supports, plus our cloud-native control networking for virtual networking. What we've done is that in IBM's Telco Cloud Lab in Dallas, all these components get put together, integrated and tested and certified for SP cloud requirements. Once you do that, you can ship the entire thing, and it can easily bring up and start orchestrating these distributed architectures using cloud-native architecture. An example of that is Telefonica, where IBM and Juniper have partnered to provide such a cloud, where Telefonica is now operating packet core, and they plan to extend that to about 24 distributed edge clouds. So that's an example of how the ecosystem can come together, open ecosystem working together to make it easier to solve the problems that are created by the 5G new architecture. Finally, the last pillar I mentioned is the slicing or radio access networks. There again, I think one of the exciting developments is that the telcos first time have opened up the architecture with O-RAN Alliance that has disaggregated radio stack into RU, DU, CU, the RIC itself, and the service management orchestration. This particular example, I'm trying to show you that ultimately for delivering differentiated experiences that 5G demands, we'll have to do slicing in an end-to-end fashion across multiple domains, RAN, transport core, and so on. In the RAN itself, if you look at it, what Juniper is first time participating in this particular environment by providing our own RAN intelligence controller as an open platform on which third-party xApps, RApps can run, including our own xApps and RApps. There you see that RApps is responsible in a non-real-time environment to construct the policies, define SLAs, define slices, and so on, and xApps run on the real-time rig. And it's an open and interoperable rig platform with open APIs, SDK, so that third-party xApp, RApp vendors can also run those on our platform. Some of the use cases that we are already supporting with this platform are with xApps and RApps include traffic steering, so that we can steer, we have steering algorithms to distribute traffic across base stations, depending on where the traffic is, whether there's some base stations are idle or not, or across radio access technologies such as Wi-Fi or CBRS. So that's a very useful traffic steering application. Slice SLA assurance application, which is about really monitoring the slice performance and then providing the assurance that you have promised. And energy efficiency is very important. By some measures, 70% of the energy consumed by networks goes in radio access networks. If that is true, then we need to make sure that we can operate those networks in the most energy efficient manner to be really the good citizens of the planet. So what we have done is we developed energy efficiency xApp, which monitors the utilization of the network, and depending on which base station is not using RAN stack, is not being used, you can transfer the traffic to another one and shut down some of the cells. That will help increase the energy efficiency. These are just some examples of xApps and RApps. Given the open ecosystem, the exciting part is that you could easily see tens and hundreds of xApps and RApps developed, which can be monetized by operators to be able to deliver really differentiated services. That's the advantage of having an open ecosystem, similar to what iPhone did with App Store, right? Operators are now talking about creating marketplaces. Dish yesterday talked about their open marketplace and so on. That's really an opportunity, in my opinion, with respect to this kind of applications. Now, one example of admission control use case here is a simple, rather than showing a demo, I just want to show you that suppose you have a simple network, you have schools, you have hospitals, and public domain. You can take your PDUs and allocate 3 slices, one for schools, one for hospitals, and the third one is public domain, best effort that anybody can use. Initially, you might allocate certain number of PDUs like 100 to public schools, 200 to hospital, and rest for the public domain use. When an emergency happens, then suddenly the hospitals might need more PDUs. In that case, you take them out of the public domain and add 200 more PDUs to hospitals while schools traffic can continue to operate. Only when school is on a holiday, you can take those PDUs away. This is an example of dynamically adjusting a slice and services necessary using the available bandwidth. And that's an example of an admission control use case. We are actually trying it out right now with Vodafone and Parallel Wireless using their RAN stack in public trial. Here's an example of a dashboard to say how an operator would monitor how the SLAs are being enforced or not and slices are operating. At the bottom, on the left-hand side, is a non-real-time RIC dashboard that shows that whenever the new policy is calculated, you see that new policy by showing the changes in the slice allocation. That is transmitted to the right-hand side, shows the near real-time RIC, that how we adjust it. So you see that the flat curve is what the expected SLA, and it starts adjusting in few seconds. Couple of seconds, it is able to adjust to provide that slice assurance. And the top is what the cumulative slice throughput is. And there are 3 flat lines, green, I'm sort of colorblind, yellow and blue, I think, and just show that how they get adjusted over a long term that you can monitor on a non-real-time break. So that's an example of SLA assurance monitoring. Most importantly, I want to emphasize the fact that we believe in a very open ecosystem with multiple players participating, cooperating. This is the first time it's happening in the RAN space. So for example, in the case of CU, DU, RU vendors, we have multiple partners. We are partnering with Parallel Wireless, as I said, at Vodafone trial. We are working with Casa Systems, another tier 1 European operator, for the use cases of slice management and end-to-end slicing. We had a partnership with, we still continue to have it, Intel, where Intel FlexRAN stack is combined with Juniper routing stack, containerized routing stack in Rakuten to deliver a 5G O-RAN-based network. We also have multiple RAP and xApp vendors writing to our open platform so that xApps and RApps can add value. Examples are AirHop, Parallel Wireless, Cohere, and many more to come. And we're also collaborating with test equipment vendors who play a critical role to provide test suites, test equipment, so that in an open ecosystem, we can really test interoperability of different components. And finally, we have a partnership with Red Hat. Our RIC has been certified to run on Red Hat as a CNF, and we continue to work with them with respect to expanding their partnership. So the key takeaway is that with 5G, end-to-end slicing is important. That's the one really brings the potential and promise of 5G services to the end users and enterprises by providing slicing and differentiated experiences. 5G requires distributed architectures, which creates a completely new complexity as well as challenge with respect to be able to orchestrate, manage day 0, day 1, day 2 lifecycle management of these hundreds of distributed mini edge clouds. But I think the cloud native architectures like Kubernetes can be used to automate that so that telcos do not have to carry that burden. And finally, the open ecosystem that Oran is really bringing in many new innovations, innovative new startups, which can start adding new value to deliver completely new use cases to our users. With that, thank you for listening. Any questions? I had 15 minutes. I went pretty fast, I think, to 15 minutes. No questions? The coffee hasn't kicked in yet. Thank you.